Trigonometry is a word that stands for triangle measure. So when I say right triangle trigonometry, I mean that we'll be studying geometry of triangles, but specifically only right triangles. And we're going to be looking at how to solve for missing angles and sides of right triangles using things we already know, like the Pythagorean theorem and relationships of angles of a triangle, and also these three trig ratios. So let's talk about what these three trig ratios are based on a right triangle. Here we have a right triangle with angle theta. This is the side opposite angle theta. This is the side adjacent to angle theta, which means next to, so touching angle theta. And this is the hypotenuse of our right triangle. It's the side opposite the right angle. It's the longest side of the triangle. So the trig ratios we're interested in are sine, cosine, and tangent. Sine of the angle, the trig ratio that's the sine of the angle, is the ratio of the side. It relates this angle to the ratio of the side opposite the angle over the hypotenuse of the angle. So it's just a formula relating the angle of interest to the side opposite it and the hypotenuse in this triangle. Cosine is a trig ratio that relates the angle to the side adjacent to the angle and the hypotenuse. So it's the ratio of the side adjacent to the hypotenuse. Tangent is a trig ratio that relates the angle to the sides opposite and adjacent to the angle. So it's the ratio of the side opposite the angle over the side adjacent to the angle. So then when I say trig ratios in this course, I mean these three: the sine of the angle, cosine of the angle, and tangent of the angle. Here we have a little phrase to help us remember the relationship of these trig ratios. So katoa, soak your toe. So, SOH for sine opposite hypotenuse, cosine adjacent side hypotenuse, and tangent opposite side adjacent. So if you're having trouble remembering, you can use this phrase to help you remember them. Here's an example for those trig ratios. So here's a right triangle, here's the right angle, so this side is the hypotenuse opposite the right angle. Then you have the angle theta here, this is the angle we're interested in. This is the side adjacent to theta, this is the side opposite of the angle theta. So we have opposite side, adjacent side, hypotenuse. The sine is opposite hypotenuse, so it's the ratio of the opposite side over the hypotenuse. So if this is the angle, the opposite side would be b over the hypotenuse would be 11. So here, sine of the angle is b over 11. Cosine of the angle would be adjacent hypotenuse. So the adjacent side to the angle that is not the hypotenuse is 6 over the hypotenuse. So you get 6 over 11 for cosine of the angle. So we can do some computation here. When you have, now you might notice this is the only unknown. There's some computation we can do to find what theta would be using this relationship. So we can find the angle using trig ratios and the sides. That's the whole point. The third one is the tangent of the angle. Tangent of theta, TOA, opposite and adjacent sides. So here's the angle. It's the opposite side, which is b, over the adjacent side, which is 6. So this would be the tangent of theta. So we can get these three equations using the trig ratios and this information, and use these to answer questions about the right triangle. This is the trig ratios for a right triangle that we're interested in this course in a nutshell.